In the dark vastness of space, a visitor has arrived, one that did not form in our solar system, but came from far beyond. It's called 3I Atlas, and today we're going to follow its journey, unravel what it tells us about the cosmos, and ask what does this interstellar wanderer mean for Earth and for us? Discovered on the 1st of July 2025 by the Asteroid Terrestrial Impact Last Alert System. Atlas's telescope in Chile, 3I Atlas also designated CC 2025N1. Atlas's was initially thought to be just another comet, but follow-up data revealed something far more unusual. The key clue? Its trajectory. It's on a hyperbolic path, meaning it's not bound to our sunday. Instead, it came from outside our solar system. It's only the third confirmed interstellar object ever observed after one ʻOumuamua in 2017 and two Borisov in 2019. That makes this visitor extremely rare, a chance to study ice, dust, and rock that formed in another star system and is now passing through ours. Let's map out the journey of 3I Atlas. According to the NASA data, the comet reached its closest point to the sunday, which is known as perihelion in scientific terms, on the 29th of October 2025, at about 1.4 astronomical units, from the sunday, roughly 210 million kilometers, just inside the orbit of Mars. Crucially, it will not come anywhere near Earth. Its closest approach to Earth is projected around the 19th of December 2025, but even then, it will still be about 1.8 ASHU, 270 million kilometers away. So there's no risk of impact or any dramatic Earth interaction from this comet. It's a fly-through. The path, it came in from interstellar space, passed by the sunday, swung out again, another visitor, only fleetingly in our neighborhood. Why is this important? Because every part of its path gives us an opportunity to see how an object formed in another system evolves when exposed to our sunday's heat, how its ice sublimates, how dust and gas are released. The real excitement comes from what this object can teach us. Let's dive into what observations have revealed so far. Composition and activity. Infrared spectroscopy using the James Webb Space Telescope, JWST, found that 3I Atlas's coma, the gas and dust envelope around, it is dominated not just by water ice, but is unusually rich in carbon dioxide. One study measured a carbon dioxide-water mixing ratio of about 8:1, among the highest ever seen in a comet. Additionally, ultraviolet observations detected O emission, which is a marker of water outgassing, at a large heliocentric distance, (3.5 AU). These results suggest that this comet might have formed in a colder environment, or under different conditions than typical solar system comets, maybe closer to the carbon dioxide ice line in its parent star system's protoplanetary disk. Tail, jets, and unusual features. Observations show 3I Atlas developing a long ion tail, a dust tail, and even an anti-tail, a tail pointing towards the sunday, a perspective effect sometimes seen. Polarimetric studies, which measure how light is polarized as it scatters off dust, found that 3I Atlas exhibits a deeply negative polarization branch at small phase angles, a value of about (2.7% at (7 degrees), and an inversion angle near (17 degrees). This behavior is unprecedented among known solar system comets, suggesting its dust grains might differ in structure or composition. Nature of the object, is it a comet or something else? Some researchers, notably Avi Loeb, propose that 3I Atlas could even be artificial, a spacecraft from another star. However, recent radio telescope observations by South Africa's Meerkat detected a natural radio emission consistent with hydroxyl, radicals, a typical marker of cometary outgassing, which strongly supports the interpretation that it's a natural interstellar comet. In short, 3I Atlas behaves like a comet, but one with some unusual traits, giving it immense scientific value. So why does this matter? Let's step back and ask, what does this single object from beyond our solar system tell us? 1. Probing other star systems, comets in our solar system formed around our sunday billions of years ago in its protoplanetary disk. 3. Atlas likely formed in another star system, under different conditions. By analyzing its composition and behavior, we get a sample even if remote of material from another system, giving us a window into how planets and small bodies may form elsewhere. 2. Diversity of small bodies, the unusual composition, carbon dioxide-rich, unusual tail, and dust properties suggest that objects forming in other systems could be quite different from what our solar system produced. This helps refine our models of planetesimal formation, ice lines, volatile content, migration of objects, etc. 3. Understanding cometary physics, because 3I Atlas is being heated by our sunday for the very first time from our perspective after traveling through interstellar space. It's an opportunity to see how pristine, untouched ice and dust respond to solar radiation, solar wind, and the inner solar system environment. 4. Public engagement and science culture. The excitement generated by 3I Atlas, including speculation about alien origin, helps raise public awareness of astronomy, of our place in the cosmos, and the fact that objects from outside the solar system can reach us. That helps drive investment, interest, and education in space sciences. 5. Earth and safety, clarifying risk. It's important to emphasize 3I Atlas poses no threat to Earth. Its distance of closest approach and orbital path guarantee we are safe. That helps dispel undue fears and instead encourages curiosity rather than panic. Now, if you're an amateur astronomer or just a sky-watching enthusiast, how can you try to observe 3I Atlas or at least follow along? Because it does not approach Earth closely, it will not become a naked eye spectacle. Even at its best, it may be magnitude 11 or fainter, requiring a telescope or good binoculars under dark skies. It re-emerged into the morning sky in November 2025 after passing behind the Sunday. Use star charts, planetary maps, and follow observatory updates, for example, the Virtual Telescope Project live streams, to know when and where it rises. Best chance, pick a location with a clear horizon toward the east, pre-dawn minimal light pollution, and be ready for a faint, small, fuzzy spot rather than a spectacular comet tail show. The key is patience, dark skies, tracking charts, and enjoy the fact you're looking at an object that came from another star. Okay, let's address a few questions and misconceptions. Will it hit Earth? The answer is no. As we saw, the closest approach is far beyond Earth's orbit. 3. Atlas poses no impact risk. Could it be an alien spaceship? While the idea captured imaginations, the prevailing scientific evidence supports it being a natural comet. Outgassing coma, tail, radio signatures of, typical for comets? Will it be visible to the naked eye? No, it is too faint, too distant. Don't expect it to be as spectacular as some great comets of the past. Why is it special if it's just another comet? Because most comets we study originate in our solar system, e.g. the Kuiper Belt, Oort cloud, 3I Atlas came from outside, so even if behaviorally similar, it holds unique clues about other systems. Is its unusual composition a sign of something weird or dangerous? Not dangerous. In fact, the unusual composition is scientifically interesting. It may reflect formation in a colder or different environment or longer exposure to cosmic radiation. That gives us new data points for models of planet building and cosmic history. So, what lies ahead for 3I Atlas and for our studies? Astronomers will continue to track it as it recedes from the Sunday and moves outward, collecting data on how the coma and tail evolve when solar heating diminishes. Space missions, for example, Mars orbiters have already imaged it while it passed near Mars. Future interstellar comet discoveries will benefit from improved surveys, space telescopes, and the lessons learned from 3I Atlas. So we may not be waiting many more years for another visitor. And for us on Earth, each of these objects is a messenger. They carry information about places and processes otherwise unreachable. In that sense, 3I Atlas isn't just a comet. It's a messenger from another world, a chapter in the story of the galaxy. If we take care, listen to what it tells us, we learn not only about comets, but about our own solar system's place in the universe, and about the diversity of worlds beyond. So next time you glance up at the pre-dawn sky, remember, even if you can't see it with the naked eye, somewhere out there is 3I Atlas, a remnant of another star system passing through our cosmic neighborhood for a fleeting moment. In the grand scale of time and space, our solar system is just one of many. This comet reminds us that we are part of a much bigger story, and that story is still being written. Thanks for joining this journey. If you enjoyed this exploration of 3 Atlas, please like, subscribe, and ring the bell so you don't miss our next cosmic visit. Until then, keep your eyes on the skies and your mind open to the universe's wonders.